Now this example 2 is another example that showcases use of your product rule to solve a differentiation question, of course, right? So here we're supposed to find the gradient of a particular curve. How does this curve look like? Well, nobody really knows and nobody really cares anyway. So we're supposed to find the gradient, the value of the gradient at the point where x equals to 0. So needless to say, we need the gradient machine, which is our dy dx, isn't it? So in this case, we are dealing with a product. Well, obviously, right, since it's an exercise, an example on product rule. So there's a product and it doesn't make sense for us to expand everything because it is too tedious to do that. So what we're going to do is we're going to apply the product rule, okay, and dy dx. So we're going to keep one of them, okay, keep this and differentiate that, okay, that whereby it is a chain rule. So we have 2 x cubed plus x, and the power remains 1. Okay, sorry, reduces to 1, right? So 2 becomes 1. Okay, so and we have to differentiate the inside, which will give us a 3x squared plus 1. Okay, so here we go. Keep this, differentiate that, plus now we're gonna keep that. Okay, which with the one we differentiate earlier on, we're gonna keep that, and we're gonna differentiate this, which is the front term, and that gives us a 6x. And that's all, 6x. So of course this is your product rule. Okay, by now it should be pretty familiar, and it's actually not that difficult, right? Okay, so then we're gonna simplify, okay, before we substitute in x equals 0. Actually we can do it at this point, but you know, it looks kind of complicated, and chances are you may just make some careless mistake along the way if you were to just substitute it in here at the moment. Okay, so if you're sharp enough, okay, and alert enough, you start to see that, hey, you know, there are 2 terms that are exactly the same. Okay, so these 2 terms we can actually simplify, right? So just like when a multiplied by a, you get a squared. So this green term multiplied by this green term, you end up with this green term square. Okay, so nothing too special about this. And what's left here will be a 2 x cubed plus x. Okay, actually you can multiply in the 2, which will become 2x cubed plus 2x, but nah, it's not necessary. Okay, so and we just continue with what we have at the back, which is 6x multiplied by x cubed plus x bracket square. So well, there you go. This is our dy dx, which is the gradient function, as well as it is the machine that helps us find the gradient at any point we want. So at this moment we are going to substitute in when x equals to 0. Okay, and we will try to figure out what is the dy dx value when x equals 0. So it's actually not that difficult for you to figure out, right? Isn't it that when this is x is 0 and 0 multiplied by anything, this entire thing is a big fat 0. Okay, and similarly over here you have a 0 plus a 0, which will be a big 0, and this 0 multiplied by a 2 is also another 0, and 0 multiplied by another 0 is well, 0 multiplied by anything is 0. So in this particular example, it's a very interesting number that we have. This is a 0 plus a 0, so the dy dx is actually a 0. Okay, which means that at this particular point, the gradient of this curve is actually flat, 0. Alright.